Hello Math Wizards, so I'm back, I'm Xavier, and for today we are going to tackle about our logbook in basic calculus, which is composed of 1001 problems, and I'm going to tackle 3 lessons on that logbook, and I'm going to be explaining at least 2 problems in that. So here we go. So this is my logbook, yes. So let's open this. So as you can see, this is my name, Xavier Francis Singcol, and these are my problems in life. I mean in logbook. Yeah. So it's 1000 all in all. So the first lesson is the limit of a function. So here we can see in our example number 1. Wait, so blurred. Yeah. The limit of x minus 2 as x approaches to 1 is equals to -1. How? So as you can see, it is stated there that x approaches to 1. So the function says x minus 2. So we're gonna substitute 1 to the x. So the result is 1 minus 2, which is equal to -1. That is why 1 is our answer. Right there. So burn, man. Yeah. So second example, the limit of x plus 3 as x approaches to 2. So the same process or mechanism as we did in number 1, we're going to substitute this value of x, which is approaches to 2, which is approaching to 2. So 2 plus 3 is equals to 5. That is why the answer is 5. Yeah, right there. That's the 5. So the next lesson is all about the derivative, but this time with a specific category, which is the product rule. So first example is the derivative. Find the derivative of what's this? Quantity of x minus 1 times quantity of x squared plus 2. So first things first is let us know the values through the process of letting. And first variable is u, which is equals to x minus 1, and its derivative is 1. Next is v, which is equals to x squared plus 2, and its derivative is 2x. So the formula in product rule is u times v, which is equals to u dv plus v du. So we're just simply gonna substitute the values which we have determined in this part. Yes, in that part. So u is equals to x minus 1. So that x minus 1. Yeah. And dv is equals to 2x. So 2x right in here. Plus v, which is equals to x squared plus 2. X squared plus 2. And the derivative of u is equals to 1. So 1 right here. So we're just simply multiply the two sides, the two variables. So as a result, 2x squared minus 2x plus x squared plus 2x, we're gonna combine both variables. So our final answer would be 3x squared minus 2x plus 2. So that's it. Next example is find the derivative of 2x squared minus 1 times 3x minus 3. So same process as we did in the first example about product rule. So the value of u in this example is 2x squared minus 1, and the value of v is 3x minus 3, and its derivative is 3, and the derivative of u is 4x. That. So going to the equation, u dv plus v du. As I've said, we're gonna simply substitute the values. So u is equals to 2x squared minus 1 times the derivative of v, which is 3, plus v, which is equals to 3x minus 3, and derivative of u, which is equals to 4x. So same thing, multiply to the two variables. So the result is 6x squared minus 3 plus 12x squared minus 12x, and we're gonna combine these two variables, and our final answer would be 18x squared minus 12x minus 3. So that's it for the derivative, specifically the product rule. So next lesson that I'll be tackling is the quotient rule about derivative. So in this example, find the derivative of x plus 1 over 2x squared. So before answering this problem, let us first know what is the process or the formula in quotient rule. So guys, the formula in the quotient rule is v du minus u dv over v squared. So it's so simple right there. So we're gonna find the values of u and v and their derivatives. So u is equals to x plus 1, and its derivative is 1, and v is equals to 2x squared, and its derivative is 4x. So going to the formula, we're gonna substitute these values. So v is equals to 2x squared right there, and derivative of u is 1, and the value of u is x plus 1, and derivative of v is 4x, and the value of v is 2x squared, and we're gonna square it once more. So this is the result, 2x squared minus 4x squared plus 4x over 4x squared. So we're gonna manipulate this equation. So we will end up with a final answer of negative 2x squared minus 4x over 2 times the quantity of 2x to the power of 4. So that's for the first example of the quotient rule. Next is this example. So the second example for the quotient rule is derivative of 3x squared minus 1 over over 5x plus 3. So the values are u is equals to 3x squared minus 1, and its derivative is 6x. Now v is equals to 5x plus 3, its derivative is 5, and we're gonna go to the formula, which is v du minus u dv over v squared, and the value of v is 5x plus 3, and derivative of u is 6x, minus value of u is 3x squared minus 1, and the value of the derivative of v is 5, and v squared, so 5x plus 3 squared. So we're gonna multiply the variables and square the variables. So 30x squared plus 18x minus 15x squared minus 5 over 5x plus 3 to the power of 2. So we will end up with the final answer of 15x squared plus 18x plus 5 over quantity of 5x plus 3 quantity squared. Excuse me. So that is the second example for the quotient rule. So as you can see guys, I have so many problems in this logbook. Yeah, this reaches up to 1000 problems, starting from here up to the last page. Yeah, 155 as you can see. Yeah, 172, 186. And by the way, this problem is all about the tangent line. Yeah, tangent line of a curve. Yeah. Yes, that. Yeah, tangent line. This is all about discontinuities, the infinite, the whole, and the jump discontinuity. Yeah, right here talks about limit once again, but a more deep interpretation of the limits. Yes, yeah, right there. Limits of infinity. This is, yes. Yeah, 250. That is the third reading all in all. And oh, I got 100. Yeah. Yeah. Fourth grading, yes. 18. 27. Yeah. So many. So this up to the last page, it reaches up to 1000 problems. So that's it. Thank you. I hope you have learned something in this video.